All right, so we're going to look at another example for solving our linear quadratic systems algebraically. And again, we can tell this system is a linear and a quadratic because we have a linear equation, and it is linear because there are no exponents. I just have an x term and a y term. And the top equation will be a quadratic because I have an exponent to the power of 2. And notice how there's only one exponent. So that would give us that parabolic shape. So yesterday we talked about rewriting our linear equation so that we could substitute it in to our quadratic equation, and that will work. So you have a lot of options when it comes to substitution. Today I'm just going to show you another possible method or strategy that you can use to find the solution to this system. So instead of rewriting our linear equation, I'm going to go ahead and rewrite our quadratic. And the reason why I'm looking at this one is because I also notice that x is all by itself. So I can rewrite this equation pretty easily by just adding 6 to both sides. So x equals negative 1/6 y squared plus 6. So you may notice that now I have an expression that is equal to x. So just like I did yesterday, I'm going to go ahead and substitute in and replace x with this expression. So I'll highlight this in the green so that you can see when I substitute it in. I'll use a green pen to show this value. So now instead of rewriting x, I'm going to replace x with this entire expression, negative 1/6 y squared plus 6. All right, so now what I have here is something that I need to distribute to get rid of my parentheses. So I'll go ahead and distribute here 2 times negative 1/6. So remember, off to the side, we're multiplying fractions. And when multiplying fractions, we multiply across. And remember, we can also cross cancel. So since 2 and 6 are a common factor, I can divide out 2 from both of them. And then when I multiply across, I get 2 times negative 1/6 is actually equal to 1/3. So if I go back here, I get negative 1/3 y squared. And then 2 times 6 will just be positive 12. Now I don't have to multiply y because it's not in the parentheses. We'll just bring y down and bring down 6. And I notice I have the makings of a quadratic, right? I have an x squared, or excuse me, a y squared and a y over here. So if I'm solving a quadratic, I need to make sure that one side is equal to 0. So if I subtract 6 from both sides so that my right-hand side equals 0, then I'm on my way to solving this quadratic. So I have 1/3 y squared plus y plus 6 equals 0. All right, so now I have a quadratic, but I have this leading coefficient, and I'm not too crazy about having fractions up here, especially if I can do something about it. So what I'm going to do is I'm going to eliminate this fraction by just multiplying by the reciprocal. And remember, when I'm solving equations, I can multiply or add or subtract or divide anything I want as long as I do it to both sides. So in this case, I'm going to say, hey, I don't like that 1/3 or that negative 1/3. So what I'm going to do to get rid of that is I'm going to multiply everything by negative 3/1. And I know that's just going to cancel out that fraction, so I don't have to worry about it anymore. But whatever I do to one side, I have to do to the other. Luckily, I already made that 0, so it's not really affecting our right-hand side at all. So now if I go ahead and distribute, I have negative 3 times negative 1/3. And I know those are reciprocal, so they should just equal 1. So I have 1 y squared. And then I'm going to multiply negative 3 times y, will be negative 3y. And then negative 3 times 6 is negative 18. And all of this still equals 0. So remember, at this point, we have some options. Remember, if we're solving, we can factor. We can complete the square, or we can use the quadratic formula. And the nice thing about these two things that you have learned so far is that completing the square and quadratic formula work for every type of quadratic. Factoring will only work with certain types of quadratics, but we know that this is actually a really easy, straightforward method once you get comfortable with it. So if you remember, I always multiply to get this last term, and I'm adding to get the middle term. So how I'm going to set this up is I'm going to use this kind of organizer to think of two numbers that multiply to get -18. But when I add them, I get -3. So the first thing I notice is that when I multiply to get a negative, I have to have a positive and a negative number. Now, when I add a positive and a negative number, it's like I'm subtracting. So now I'm thinking of two numbers that multiply to get 18, but when I subtract them, I get -3. And I realize, hey, that has to be a -6 and a +3, because -6 times 3 is -18. -6 plus 3 is -3. So now I have enough information to factor y plus 3, y minus 6, and that will equal 0. So at this point I have factored, and remember I have this zero product property, which means I'm multiplying and the product is 0. So the only way to multiply and get 0 is that if each of these factors equals 0, or at least one of them does. So I'm going to just see what happens. What are those values where these would be 0? And I can see that y will equal -3 and x will equal, oh my gosh, y will equal -3 and the other y will equal 6. So far what this means is I have the beginning of two solutions. I have a -3 and I have a 6. So all I need now is my x coordinate. So how do I do that? Remember, I have to substitute in my y's back into the equation, and I have to solve for x. So I'm going to pick the easiest equation. I'm going to pick this one right here, 2x plus y equals 6. So I'll rewrite that down here. 2x plus y equals 6. And now I'm just going to substitute in -3 and +6. So 2x plus -3, and then I'll also substitute in 6. 2x plus 6 equals 6. So I know if I'm solving this, my first equation, I add 3 to both sides by 3. So 2x equals 9, and then I have to divide that by 2. So x equals 9 over 2, or I know how much you guys love decimals, so 4.5. And here, if I do the same thing, I'm going to subtract 6, and I get 2x equals 0, which makes our problem pretty easy to solve. And now I just have to go back and write these as ordered pairs. So I already know what my y coordinate is. So now I just have to use my x coordinate in the right spot. So here I had a 6 for y, so 0 will be x. And for this next one, I had a -3 for y, so 4.5 will be my x. So again, our goal is to solve the system of equations, and that means that we are going to be getting ordered pairs as our solutions. We can have one solution, we can have two solutions, or we can have no solutions.